So, a very good afternoon to all of you. And what we would like to do now is we would like to continue from our last equations that we developed. As all of you know that we have been talking about non-degenerate perturbation theory. And what we did yesterday is we started from a perturbed Hamiltonian and and finally we came across an equation in which on the left hand side you have the coefficient of lambda naught, lambda square, and the same coefficients on the other side of the equations. And to make that equation consistent, so that the equation is true, what was essential was that the coefficient of these lambdas, they must be equal. And in doing so, what we did, we obtained equations. Okay, so let me write down the first equation that we obtained was the eigenvalue equation for unperturbed Hamiltonian. If I rightly remember, it was H naught psi psi n naught equals E n naught psi n naught. And this was it, and we exactly know how to solve the problems which does not involve any kind of perturbation. The problems which are purely idealistic in nature, we know how to calculate the energy eigenvalues of those equations. So the second equation that we obtained, what was that? The second equation that we obtained was
H naught psi
H naught psi n 1 plus HP psi n naught. Okay, this is equal to E n naught psi n 1 plus E n 1 psi n naught. Okay, right? So we will see now that we would like to solve this next equation. We would like to project this equation so that we can calculate the first order correction to our problem, right? So what should I do here is, what I have the ket of psi n naught, okay? And what will be its bra? It will be bra of psi n naught. So what will I do here is, I would like to multiply this equation from left by psi n naught. So I would be multiplying this equation by the bra of psi n naught. Is this clear? Okay. So we have to multiply it from the left. Okay. So when we do that, can I proceed? Okay. So what can we do? We will have psi n naught, come on, H naught, psi n 1, right? Plus psi n naught, then you'll have HP, then you'll have psi n naught, alright? Okay, this is equal to, come on, this is psi n naught, E n naught, psi n 1. Then plus, you will have psi n naught plus E n 1 psi n naught. Right? Okay? Now, again, we understand that the bases that we have chosen, the vectors that are involved in our problem, they obey the basic rules like orthogonality properties. So what will happen here? If I have something like psi n naught and psi n naught, this must be equal to 1, and psi n naught and psi n 1 is equal to 0. See, what's the point of contention here to understand is that you have the same basis. When you have the same basis and you have 0 and 1 states, they are orthogonal to each other and their value is 0. But if you have the same framework and you have different bases, in that case, you cannot equalize it. You cannot equalize this kind of thing to 0 in that case. If you have two different bases for the same problem. Getting my point? Okay. So what we can do here is now we would like to. What is this? This is psi and naught acting on H naught. What you'll get out of it? Come on.
H naught.
Yeah. Yeah. It should be because you can. It's your energy eigenvalue equation in terms of bra, okay? Bra vectors. So for that, here you will have E n naught. That's a number that will come out of the matrix, right? So that will come out of the matrix. Here you cannot do anything like that. Again, here E n naught is a number. You can get it out of the matrix, right? What will be left here with psi n naught and psi n 1, okay? So psi n naught and psi n 1, that will give us 0. So this thing will be equal to 0 and this thing will also be equal to 0. So what we'll be left with is En1, okay? En1, I can get it out because it's an energy eigenvalue. It's the correction to the energy. It's the first order correction to the energy. So what will be your equation then? Your equation will be like En1 out. So you will have psi n naught, and then you will have psi n naught. This is equal to the matrix element of psi n naught HP psi n naught. Okay? Now this thing is immediately equal to 1. So you have a correction. You have the first order correction in energy. And that is equal to psi n naught HP psi n naught. Now what is so strange about it? Come on, that's very important. What do you find that's compatible with the philosophy of perturbation? What is that? Come on. Can you tell me? Yes. The beauty of this equation is that the perturbation that you have introduced to your system, you can calculate it in terms of unperturbed eigenvectors. Psi n naught, these are unperturbed eigenvectors and you know how to calculate them. You exactly know how to solve them, right? So this is your first correction. This is the correction to energy. So do you remember that En, what was it? It was lambda naught. En naught plus lambda. En1 plus so on and so forth. Now if I have to go with the correction in energy up to the first order, what will be that correction? That will be En equals En naught. Am I right? En naught is exactly calculable plus the matrix element of psi n naught, HP and psi n naught. So this equation will lead us to the first order correction to the energy. So we can even think of writing down this matrix element, right? So you have a matrix element, how can you write it down? This matrix element psi n naught, HP psi n naught is going to be, you have a matrix HP, say 1, 1, HP 1, 2, and this will all the way go to HP 1n, alright? So then here you will have HP 2, 1, then you will have HP 2, 2, and this will all the way go to HP 2n. Okay, this will come down, this will become HP n1. Okay, so So this way it will go down and you will have H, P, and so I should take this M. If I take this M, then this will be H, P, and M. Alright? So you can choose this one as M. So this is your matrix, and the diagonal elements of this matrix will give you the corrections. So the diagonals of this matrix element will give us the energy eigenvalues, the correction that you are introducing to your system by introducing the perturbation to your problem, right? Okay, so this is the story of correction in energy. Now the next story is, if there is correction in the energy, there has to be the correction in the eigenvector also, right? So the next thing that we would like to do is to evaluate the correction to the eigenvector. So can I move on from here? Okay. Now, first order correction. Now you can proceed for the second order correction in energy. That you can do yourself. You work on that and you'll solve that. Now, the first order correction in eigenvector. Okay? So, what will be the first order correction to the eigenvector? The first order eigenvector, I can write the cutoff, psi n1. I want to calculate this. This is something that I want to calculate, right? So, everybody among us knows if I multiply anything by an identity, you'll get the same thing. So I can think of writing down this eigenvector as I psi n1. Any objection? No, there should be no objection in doing so. And I can write down this I as the cutoff. I will choose another basis. What am I doing? I'm choosing another basis in the same framework as psi m. I write its outer product, psi m. It has to be psi m naught, unperturbed basis, and then I will write a bracket for it. I would like to write I here as a summation where m is not equal to n. This is my condition, and then I have my original psi n1. Right? Okay? I'm framing it, okay? I have been framing it, so what can I do here? I can rearrange these cats and bras. Okay, what can I do? I can write down this as separate, and I can get this out. Okay? Okay. This is an outer product. I chose a basis I know, right? And if you take the outer product of the same eigenvector, that is equal to identity. Okay? So for identity, I'm writing this one. And what is important here is this m is different from that of n. Okay? So m is not equal to n. So now, writing this, I can incorporate the bra of this newly chosen basis. Okay? I can write this as the part of this. So this part I can write outside. Are you getting it? It's so simple. So what can I do here is, what will be my psi n1? It will be sigma m not equal to n psi m naught psi n1 and psi m naught. Is this clear? Okay, you can see all I have done is I have got this one on the outer side. Okay, now in the inner side, what I have I have the inner product between psi m naught and psi n1. Do you remember? When I talked about orthogonality, psi n naught, psi n1, that's equal to 0. But that's not the case here. Why? Because you have two different bases. Okay? So here, this thing is not equal to 0. So what is it? This thing we would like to calculate. We would like to calculate. If we calculate this, we have obtained the correction, the first order correction to energy eigenvector. Clear? Okay, so can I move? So this is my target. Where from I will achieve this target? You again tell me that equation. The equation number 2, what was that? It was H naught psi n1 plus
HP
psi
psi
n naught. This is equal to
n naught
E n naught
psi n1
plus
n1
E n1
psi n naught.
psi n naught. Right? This is our equation. And what's our target? Our target is to calculate this. Right? The inner product of psi m naught and psi n1, which is not equal to 0. Right? Okay. So for that, what I'll do, I would like to multiply this equation from left by psi m naught. Okay? So what am I doing? I'm multiplying this equation by what? Psi m naught. Okay? So for that, I should write another equation. That will be the right thing. So come on, what will be the first thing? Yeah? You will have psi m naught, then h naught, then psi n naught. Is this clear? Clear? Plus, yeah, the next term will be psi m naught, then you have perturbation, then psi n, come on, what is that? Psi n1, that's 1, okay? This is equal to psi m naught, then E n naught, E n naught, psi n, yeah, come on, what is it? Psi n1. Okay, then plus, you will have psi m naught, come on, E n1, and then psi n naught. Okay? Getting my point? Okay. So, come on. What do you have? Yeah. I am multiplying from left by psi n naught. The bra of psi n naught. Okay? Where? Here.
Yes.
Okay, okay, that's correct. Okay.
आगे not psi n naught HP के आगे
Psi n
not
naught. Very nice. So I have done it wrong. Okay, you have corrected it, that's fine. Okay? Now, you can think of H naught psi n. Okay? You can write down the energy eigenvalue for psi n. What would be that? H naught psi m is E m naught psi n. Clear? So I can also write the bra of it. Bra of psi m naught. Psi m naught. Psi m naught of H naught will be E m naught psi m naught. Would it be like this? Because once you operate the Hamiltonian, you get a number. So number you can place on the left or the right, it doesn't matter. Right? So what you will get from this term? This will be E m naught. Right? E m naught. Getting my point? So this will become psi m naught will be there because your operator is a Hermitian operator. You will get the same eigenstate. So what you are getting here is E m naught. Okay, this thing is resolved. This will remain as it's. Okay? Now what about this? In this case, E and naught is already a number. It will come out. So what will be left with? Psi m naught, psi m1. And this thing will automatically perish. This thing will perish, and you will tell me why it will perish. Because psi m1, psi m0 does not perish, but their zeros perish. Okay? So you can do that. So what we are left with here in this equation? Come on. I'm left with, so see, I'm left with, okay, I'm left with E m naught, then psi m naught, psi m1. Correct? This is the first thing. Plus, the second term is what? That is psi m naught HP psi m naught. Am I right? Okay, what will be the third term? This is equal to E m naught psi m naught and psi m1 plus 0. Okay? See, these two are common, right? This is the same inner product. What can I do? I can either take this on the right hand side, so I will have E m naught psi m naught psi m1. Okay, this is there. So this will go on the other side. It will become minus E m naught psi m naught and psi m1. This will be equal to psi m naught HP. You see, again your HP is in unperturbed framework. Psi m naught. It's again in the framework of unperturbed. You are calculating your perturbation in terms of unperturbed, which is exactly calculable. So now, from these two, you can see psi m naught and psi m1 is common. So what will be left with? E m naught minus E m naught. So you will have E m, is it n first? N. No, is it m? N naught minus E m naught. Come on. Then psi m naught psi m1 is equal to, come on, it's equal to the matrix element of psi m naught HP psi m naught. Clear? Is this clear up to this? I think you can see that we are achieving that what we are interested to calculate. So this inner product psi m naught and psi m1 will be equal to psi m naught HP psi m naught divided by E m naught minus E m naught. You can see the failure of this perturbation also in this equation. Because if n is equal to m, you are getting the things as failure for this theory. But what is necessary is that n is not equal to n. Is this clear? So this thing is calculated. So where would I substitute this? You remember that equation? What was that? I would like to substitute this value in my original equation. What was that? That was the first order correction. It was psi m1. This is equal to sigma m not equal to n. Otherwise it will not exist. Okay? The things that we have developed till now, it will not exist for m equal to n. And here you have a matrix psi m naught HP psi m naught, right? Divided by E m naught minus E m naught. This is whole multiplied by psi m naught. So this equation will give you the correction, the first order correction to the vector, to the energy eigenvector, right? So for that, if I have psi n, what is psi n? You know, psi n is lambda naught, psi n naught plus lambda psi n1 plus so on and so forth. But we have calculated the correction to the first order term. So what will be your overall eigenvector? Your overall eigenvector will be psi n naught. This is the eigenvector of the unperturbed system, which is exactly calculable, and plus lambda times psi n1. And what is psi n1? This whole thing, this whole shit is your psi n1. What is it? It is sigma psi m naught HP and psi n naught divided by E n naught minus E m naught. This will be multiplied by psi m naught. Right? So this will be multiplied by the ket of psi m naught. So this equation gives us the first order correction to the energy eigenvector. And you can, in the similar fashion, you will write down the matrix element, you will calculate the matrix element, and in this case, all the values that you have on that matrix which are off diagonal, they will give you the energy eigenvalues. In the previous case, the elements that are lying on the diagonal of that matrix lead us to the correction in energy eigenvalues. But in this case, the elements that are present on, that are off diagonal to that matrix will lead us to the calculation of energy eigenvalues. Is this clear to you? Okay, so the same story can repeat now for the second order correction. That will be an assignment to you, so that you will work on that and calculate the second order correction to the energy and the second order correction to energy eigenvector. So with this, anything else you want to ask me anything? Okay.